This is Unit 7, Lesson 8 of our Calculus class. Unit 7 is Applications of Integration. Lesson 8 is called Washer Method. In this lesson, we're going to learn what is washer method and how to calculate volume using washer method. So when I grew up, did a lot of construction with my dad, and one of the little fasteners we used on screws was called a washer. And so a washer is this little disc-like shape. You could imagine just a circular piece of metal with a circular hole inside of it, and use that to make a bigger flange on a screw. So we care about that in this because if I take a shaded region as such, and it's rotated around a horizontal axis, but there's a gap between the axis of rotation and our shaded region. If I rotate this thing, what it's going to do is create a hole in the center, so that if we cut any cross-section, any vertical cross-section, the cross-section is going to look like a washer. Okay, and so again, we have a circle with a circular hole in the center at any given point. So to find the volume of this rotated shape with a hole in the center of it, we're basically doing washer method to find the volume of the whole thing, and we're going to do disk method to find the whole thing, and then disk method to find the hole in the center of it, and just finding the difference of the two. And that's kind of the concept behind washer method. And so the radius from the axis of rotation to the outside of our solid shape that we create, and then the little radius, lowercase r, we take this axis of rotation all the way to the inside width of that hole in the center. And so we have a big R radius and a little r radius. And the difference of the two is going to create our region of solid mass created by this rotating volume. Okay, so then if I find our intervals from x values a to b, I'm going to calculate big R, and big R is going to be our top function minus our axis of rotation, and little r is going to be our lower function minus axis of rotation. And we're just going to calculate the difference of those times pi. And of course, pi is a constant, and so since both terms, capital R squared and lowercase r squared, are being multiplied by that constant pi, I can just factor out pi and even pull it out of the integral altogether. So we can go pi from a to b of top function minus bottom function squared minus, top function minus the axis of rotation function squared minus the lower function minus the axis of rotation squared dx. So that's our setup for washer method right there. Alright, so some examples here. If I put some names to those functions, the top function f of x is equal to e to the power of x. Our lower function is the horizontal line y equals -2. And our axis of rotation is the horizontal line y equals -4. Okay, and so if I set this up, our big R is going to be the top function minus the axis of rotation, so e to the power of x minus -4. We'll square that, and then we'll subtract the bottom function minus the axis of rotation, so -2 minus -4. Now, we can do this by hand, but I want to show you again using your calculator. So let's do that right now. Got my calculator pulled up. And this time when we do this, we're going to use Math 9. But first, I want to make it clean. And since we've got a lot of stuff going on in our integral, I'm going to type some of this into our. We're going to use our y bars stuff to do this. So the top function, I'm going to put e to the power of x plus 4, and I'm going to square that. So we go brackets, and our e is a blue function, so second natural log, e to the power of x plus 4, close brackets, and I'm going to square that, and that'll be our big R function squared. And then I'm going to put negative 2 plus 4. Well, that's just 2. So I'm going to just throw in 2 squared would just be 4. So I'm just going to put 4 right here. Alright, so now we're set up. Yeah, negative 2 plus 4 is 2, and then 2 squared is 4. So that's going to be that. So now when I leave our y equals page, I'm going to type in math 9 to pull out function integration. Instead of typing out this whole expression, I have each piece programmed in as y1 and y2 respectively. So I'm going to type in, let's see here, I'm going to go to vars. I'm going to pick y vars. I'm going to pick function. And then y1 is programmed already to be e to the power of x plus 4 squared. So I'm going to pick that function. And I'm going to pick subtract our y1, which is just 4. So I could just write 4 right now. But for the sake of showing you y vars again, go vars, scroll over to y vars, pick function, and then y2 is programmed as 4. So we're just going to do that. Alright, so there's our big R minus little r squared. We're going to go comma. We're integrating with respect to x. Our lower bound is 0, and our upper bound is 2. Alright, so we'll type that in, we'll get that answer. The one thing we haven't done so far is include that pi. So I'm just going to go second caret, get that pi symbol, times, and then I pick second entry. Oh, wrong one. Second caret to get pi, times, second, and then ANS is answer. So I'm going to pick this one right here. So what we're doing is we already have this program as our answer. So I'm going to multiply our pi times that answer. That gives us the final answer of 320 with some change. So that is the volume of this shape. Alright, one more example I'll show you just to set up here. So we have a top function, x, the square root of x. The bottom function is 3y equals x. And rotating around this axis, y equals negative 2. So big R would be the top function minus the axis of rotation. So in our interval, the square root of x is the top function. So the square root of x minus negative 2, we'll square that. The bottom function is solved for x, so we want to solve that for y. So if I solve this for y, I'd just be dividing both sides by 3. So if 3y equals x, y would be equal to 1/3 x, or x divided by 3. And then we'll subtract negative 2, and we'll square that. So we have big R squared minus little r squared, and we're integrating from 0 to 9, and I got those numbers just by reading the beginning and end points of our region, and then multiply that by pi, and we're good to go. Alright, so this is how you use washer method, very similar to disk method, and the graphing calculator is still very helpful.